Hello everyone, this is our technical demo of basic 2D data visualization. So today we'll use a set of data that is retrieved from the data hub related to the global average absolute sea level change from 1880 to 2014. And the data is from the US Environmental Protection Agency. We can retrieve the data from here. They already attach the CSV file here, or you can use JSON. It depends on your preference. But in our demo, we will use CSV. And I also attach this file in the following link of the video. Okay, so let's see what we will have in the end of this video. So basically, we will create a web-based 2D data visualization, and we'll have the title show up here in the description under the title. And we also have a graph, the chart, and the chart is showing the trends of the sea level change from 1880 to 2014. Once our mouse hover over the data points, you will see like the specific months and also the sea level numbers in millimeters. And we also have the separation line to separate each year. So basically the blue line starts, it will be like the January, and this will be the December, and the blue line will indicate the next year. So it basically separates this whole graph into each year, and the gray line means the month. So that's what we'll have in the end of this technical demo. Okay, so let's start. We need to go to the editor, P5.JS editor. And then we need to create a folder. Let's name it as assets. So let's upload our CSV file to the assets folder, okay? So click upload file and let's drag. And then once it's successfully uploaded, let's rename this CSV file to sea level. So just something simpler, okay? So we have the sea level CSV file ready. So we can see there's two columns in this table. The first column is each month of each year, right? It's basically the date. And the second column means the sea level numbers. Let's go back to the main file. So we can always rename our JavaScript file to a different name. So for my example, I would like to rename as main. And don't forget to relink JavaScript file with HTML files. Let's say main, okay? Again, I need to point out this important idea of P5.JS library is the function setup means to initialize the whole program. So it only runs once in the beginning of the application. Function draw is looping forever, it's executing forever. So any kind of motion interactive components, we should definitely put into function draw. So I hope you guys can make clear the differences between those two functions. And now I'm going to introduce the third function. It's function preload. So basically any kind of media elements, external media elements we put in the assets, we definitely need to preload it before the program starts. So let's create a function called function preload. So if you have any questions, just visit help, reference, and search preload, and it will have a detailed description of it, and it will also attach examples. So definitely use the references anytime you have any confusions. Okay, so the next step is we need to load the table. So if you go to the reference page, and let's say load table, and you already have the load table method here. And so basically it's two steps. The first step is to create a variable first, and then the second step is to load table. And thirdly, we can use a lot of interesting and very helpful methods such as get row count, get column count. So basically it will return the total numbers of the rows, the total numbers of the columns, and we can also get numbers, get string to get the specific information in specific row and column. So we have a lot of things we can do with table. And if you search table here, and you can see we have so many methods you can use, like add row, remove row, get rows, find row. please explore by yourself. So this is very interesting points. And so firstly, we need to preload the table. So let's create a variable of table first, let table, or you can name it differently, like let's see level, whatever you like. Okay, so I will just name it let table. And we need to say table, load table. And let's find out the routes. So it's in the assets, and the format is CSV, and include header because we already have header. Okay, so header is the first line. If you have like the time at GMSL, which means we have a header, so definitely include it in the load table. And next step is we need to prepare our data. So basically we will get the basic information of the data. Let's create a variable like let number rows and number columns. So we want to know how many rows we have and how many columns we have. Okay, so get row count and get column count is the built-in method. It's basically count the total rows and total columns. And let's test. Let's say print. And okay, so let's see if we have the rows and the columns. Yes, so we have see the console. So anything you print it out, it's basically will show up in the console. Okay, so we have rows numbers. We have 266 rows, and we have 2 columns. So everything is correct. And we can comment out this print. This is just to showing up like if the lines of the code is executing properly. Let's resize the canvas. Okay, so let's color the background differently. Let's do 240. Okay, so now we have the background and we have canvas, and we successfully load our table. And the next step is we need to load data. So for loading the data, we basically need to create a for loop to access every row of every column, right? So let's create a for loop. If you have any questions with for loop, again, go to a reference page and search for, or there's a lot of online kind of materials, videos, tutorials about for loop. And this is a very important key ideas of the programming language. So definitely you should fully understand for loop before you start coding. So R represents a row here, and we need to access every row of the first column. And we need to create 2 different array. So the first array means the date is represent the first column. Array can represent a list of elements. The elements can be different kinds of things. For example, numbers, string, objects, different kinds of variables. If you have any questions with array, check out the array tutorials. Okay. So we need to create another array. Okay, I will name it as GSML. GMSL stands for Reconstructed Global Mean Sea Level in millimeters. Okay, so that's GMSL means. Okay, so let's go back to our editor, and so let's name it as GSML. Get the numbers for the date and get the numbers to the GSML in 2 arrays. Firstly, date, we need to use the table dot get string because it's string, and R in 0 means the first column with every row of this column. So in P5.JS, the first column is start from 0 and second column is 1. So it's like this. The first number in the array is 0. Next, we will create a GSML table get number. Let's print it out. Let's see. Okay, so see from the console, we already have the data set successfully loaded, and that's great. Next step is we need to find the minimum number of these data sets and the maximum number, because we will use the minimum and maximum to map to normalize the data later. Create a new function called minimum and maximum. We need to create the data minimum and data maximum as a variable, And let's set the data maximum to be 0 in the beginning. Let's create a for loop because we want to access every element inside of these data sets. We need to go over data sets, the second column. So I'll say if anything inside of this table on the in the second column is larger than 0, then the data max will be that number. So if we go through this whole column, we will find out which number is the maximum number. So basically we will use for loop to do that. Okay, so data max will be that number. We will say data minimum to be the data maximum. So we will attach the numbers we find out to be the maximum data to the data minimum variable, and then we will create another for loop. We'll go over this column again. We'll say if the number is smaller than the data minimum, and then the data minimum number will be that number. Using print again to test if this function well. Okay, so let's comment out this print. So we forgot to include this function to the function setup. Okay, so we can include this minimum, maximum, these functions to the function setup. Okay, so we know maximum value is 79.5 and minimum number is negative 3.5. Okay, so we successfully get to know like which number is the minimum and the other number is maximum. That's great. We'll start to visualize this data sets. The first thing we need to do is create a diagram. Let's set the charts in the specific position of the canvas. Let anything outside of two functions, it will be like global variable, which means every places of the functions, we can all access those global variable. If we create the let like the variable inside of the function, then only the code inside of the same block can access the local variable. So that's the difference. Okay, so we will say let diagram x and diagram y, which means the x position and y position, x coordinates and y coordinates of the whole diagram. We will say diagram x is, because I want the diagram in the position that is correlated to the width, because if we show it in full screen, it will be different kind of positions. I want to have it, no matter if I shrink the window or not, it will have correlated positions. Diagram y is related to the height, so it's always in the center of the height. Okay, so that's what we have. So basically we need to do some calculations so that we can know where to map each data to, because it's a circular shape, so we definitely need to calculate it. So basically we need to know the radius of this circle, right? And then we need to know the data, like the data offsets of this each line. So basically we need to know like this length, and then we need to know the angle of rotation, and we use sine or cosine to know the x and y positions of each data. So let's get back to the editor, and then we need to know like the radius. Let radius to be I would say width divided by 5 minus 100. And we also need to know the angle. So the angle is 360 divided by how many rows we have, and this is the angle, right? We need to do some calculation then. So let's create a for loop and let I. Basically we create this for loop to access every number of the second column, so we can have all the rows loaded. And then we create a size. Size means the length of each line. So here, from here to here, from here to here. Let's create an array, a map function. The original number is the minimum number is negative 3.5 and the maximum is 79 something. So we already know the minimum and the maximum. So we definitely need to map the minimum and maximum to a specific range because we need to normalize it, right? Oh, we missed the S. And let's run the minimum and maximum value. Okay, so we need to map it from the minus 3.5 and 79.5 to something else. I would say 0 to 205. So it can be any other numbers. But here, map is very, very important method. If you search the reference page and map, it let you know like map is from the incoming value to be converted and to the lower bound of the value's current range, upper bound of the value's current range, and map it from there to lower bound of value's target range and upper bound of value's target range. Okay, so here we need to add what kind of value we need to map is GSML I. So basically it is the second column of the table. Every row of second column of the table. So this is we have. And next step is we need to calculate each data point's X position and Y position. And we need to do some calculations. So for X position will be cosine and radians, angle, multiplied by I. I means, right, each row. I will plus diagram X. So I will like move the whole diagram to one specific position. And let the point Y. The only difference with Y position, X position is we use sine. And okay, so next step is we need to draw the shape. Let's say circle. Let's give it color, fill blue, and let's say 4. Okay, so the next step is it doesn't have anything showed up because something went wrong. Go back to here, to the load data. I accidentally put 0 to here, but we actually need to put 1 to here, okay? So 0 means to access the first column, and 1 means access the second column. So we GSML means the sea level data. It's on the second column, so it's 1. Okay, so let's run again. Okay, so we have the data showing up. It's great. Firstly, let's put no stroke because I feel like the stroke weight is too distracting. So we have this kind of like data distributed in the circular shape. And then let's go back to our results. Basically, we need to have the lines to connect the data to the center, like the circular shape. And let's draw this line. So let's create a variable, say circle x, and it means the x coordination of the circular shape in the internal circles, and equals to basically the radius multiplied by cosine. Again, plus by diagram x. We need to copy paste and we change it to sine. Then we need to draw the indication line and stroke weight 0.3. And then we need to draw the line. Lines from the first point X and Y position to the second point X and Y positions. So first point will be circular shape, X position and Y position, and second one will be the point X and point Y. Okay, let's run again. I feel like the stroke weight is too heavy, so let's change it to 0.1. Looks better. And let's see, let's save it and let's click on share and see the full screen. Okay, so the full screen looks much better, right? And let's get back. Let's rename this file to demo. And then the next step is we need to separation different kind of blocks for each year. And we need to change the one means the January, like the first month of each year, the line will be in blue. We just create an if condition. Else, okay, let's run again. Okay, see, we have those lines marked. Okay, I will explain this one now. So this symbol relates to the modular, okay? So the modular, we often represent it by this symbol. If it can divide it by 12 and the remainder is 0, paint it blue. Other conditions, we will paint it black. Save it and let's get back to see the full screen version. So we have the blue lines to separate each year. And let's get back to the editor. I will change the stroke weight to 0.5. Okay, looks better. Okay, so next step we'll do the hover effects. If the position of the mouse is close enough to one kind of data point, and then the data points will become a red bigger circles and with specific numbers showing up to let the audiences know like what is the data and what date it is. Let's go back to our results. So if I hover over these points, we will see the sea level and date in the center of the circle. So let's go back and we need to use a function called distance. This is a method. It's really important. Let's go back to the reference page. So distance means calculations of the distance between 2 points. The first 2 parameters means the x and y coordinates of the first points. And second, the third and fourth parameter means the second x and y coordinates. The first point will be mouse x and mouse y, right? And second point will be the point x and point y. So this is the distance between the mouse and our data point. And then we will use the if condition. So if the distance is smaller than 5, we will have the circles in red. The circle is blue. Okay, so we have the circles in red. And we also need to change the size. So let's say, and let data size, okay, 3. So if it's hover over the data point, the data size will enlarge it. So it will be 10. Else, it will be 3. Let's run again. And next step is we need to show up the information, right? So if it's smaller than 5, we will show our information. Okay, so we will draw text. Align is center. Text size 12. And text position will be diagram X and diagram Y. Okay. And let's change the circles to before the text. Okay, so that the text color won't affect on the circle's text, the circle's color. Okay. And let's fill the text to be black. Okay, so we have the date showing up. And the next step is we will show sea level GSML. I want this the number of the sea level under the date. Okay, so we have 2 numbers showing up properly. I want to create some visual hierarchy, so I want to change the text size to be 25. And I also want to create a highlighter like a rectangle to actually block both 2 numbers. So create a rectangle. I want the rectangle to be blue. And the size of the rectangle is 30 by 5. Okay, so we also need to change the rectangle mode to be centered. So I would like to put it in setup. We can also put in draw, so it really depends on your preference. But if we put in setup, which means all the rectangles in this canvas will be centered. So I would like to do that. Okay, so we have this indicator working fine. And the next step is we need to draw the information of this whole diagram. And let's create a customized function. And because this chart info is not interactive, so we can directly put in the function setup. So chart info here. And let's create a text size. Be 16. And I want the text align on left. And fill it black. And the text info, I want to copy and paste information here. Okay. Copy and paste. Okay, so so the position of this text, we need to, let's see. See, now we cannot see anything because we didn't create the text wrap, which is very important because if we create a text wrap in the fourth parameter, we can actually wrap the text in different kind of format. For example, 50, it will be like narrow down the blocks. You see the difference, right? So for here, we need to create a text wrap. Oh, actually we cannot put the chart info in the setup. It's because we will run the draw with the background. So if we put in the chart, put in the setup, it will definitely show up in the beginning of the program. However, because the function draw is looping forever, so the function background will cover over the chart info. So we will no longer see the text information. So we'll definitely cut the chart information after the background. Okay, so now we have everything showing up. And next step is we want to draw the main title. Okay, global average, and we'll put the position. Okay, let's run again. So although you see it's kind of overlapping the text, but you will see it in much different kind of format in a full screen version. Let's save it first, and then let's get back to the full screen version. So we have everything showing up, the main title and also the description. And when we hover over those data points, we see the information. So this is for the technical demo, the first technical demo of 2D visualization series. And the next technical demo will introduce the interactive components with a slider to adjust like the range of the data, and there's a lot of possibilities with customized buttons, sliders. Okay, so I hope you enjoyed this technical demo and have fun.